This lesson we'll learn about the areas of parallelograms and triangles. The objective is to find the areas of parallelograms and triangles, so we'll look at the formulas to do that. The first theorem is about the area of a rectangle. Rectangle actually is a parallelogram with 4 right angles. So the area of a rectangle is the product of its base and the height of the rectangle. So area is base times height. The next one is the area of a parallelogram, which is also going to be the product of the base and the corresponding height with that base. So there's a slight difference there, so let's look at that. So if the area of a parallelogram is the product of its base and corresponding height, what does that mean? The base of a parallelogram doesn't just have to be the bottom side of the parallelogram, as it is in the diagram on the left. The base could be any side of the parallelogram. So if you look at the one on the right, the base is actually that left side, is what they have designated as the base. So once you decide what your base is going to be, the height is going to be the distance from that base, the perpendicular distance from that base to its opposite side. So that's why in this particular one on the right, the opposite side, in order to get perpendicular to that opposite side, it had to be extended, and then it could be perpendicular. So this is actually the height here on the outside of that one, which is its altitude. So here, that's what that says below. The base of a parallelogram could be any one of its sides, and then the corresponding altitude to that base is a segment that's perpendicular to the line containing the base, drawn from the opposite side of the base. So that height for your formula, base times height, is going to be the length of that altitude. So now let's look at the relationship between parallelograms and triangles. So if you take a triangle like the one on the left here, and you can rotate a triangle about a midpoint of a side, and then if you do that, you're going to form a parallelogram. So once again, if I took the midpoint of this side of this triangle and rotated it about that midpoint, then you're going to end up with a parallelogram. So this is where we get the formula for the area of a triangle, is because a triangle is actually half of a parallelogram. So if the triangle is half of the parallelogram and the area of the parallelogram is base times height, then that means that the area of a triangle is going to be half the product of the base and the corresponding height. And the corresponding height means from the base that you've selected. From the side of the triangle that you select to be its base, then its height is going to be the perpendicular distance from that base to the opposite vertex for that triangle. So once again, the base of a triangle can be any one of its sides, and then whichever side you choose to be the base, the corresponding height is the length of the altitude of the line containing the base. So in problem 1, you're finding the area of parallelograms. formula for the parallelogram area is base times height. You choose, in this diagram, the base is going to be the 8 centimeter length. And then the height is the perpendicular distance to the opposite side. So it's the 7. So 56. And area is always in units squared. So units here were centimeters. So it's 56 centimeters squared. In the B part, the base is the 12 inches. And then the distance from the side that's 12 to the opposite side, the perpendicular distance, is 5 inches. So we have 60 inches squared. In problem 2, you're finding a missing dimension. In parallelogram ABDE, they tell you that AE, so the length of segment AE is 12, and the length of segment AB is 9, and the length of CB is measured on the outside, so it is a height between DE and AB is 10 centimeters, and it wants you to find the height that's on the inside. The height that's on the inside of the parallelogram, which is the length from D to F. So we need to find the area of the parallelogram using these dimensions. Let's let the 9 centimeter be base 1. Okay, so if this is base 1, which one of these dotted line heights goes with that base? It's the one that's measured from that base to the opposite side. So the one that goes with it is the 10 centimeters. So we're going to say that's height 1, the 10 centimeter. Those go together. That height goes with that base. So then, as we're looking at this, the 12 centimeters, if we look at it, this is going to be, if we look at that as a different base to that same parallelogram, which distance would be the height that goes with that base? The height is going to be from that base, the distance, perpendicular distance to the opposite side. So this DF is going to be the height that goes with that base. So the first thing we need to do is find the area based on the first base and the first height that we've marked. So the area of the parallelogram is going to be base 1 times height 1, the height that corresponds to that base. So that's going to be, base 1 is 9, and the height that goes with that base is 10. So that's 90 centimeters squared. So now use that area, and that's going to allow us to find the other height. If we turn it and go the other direction, the area would be, if you looked at it from the perspective of the other side being the base, the AE being the base, that's at base 2, and it's the height that goes with it. We know that that still has to equal 90, so we're going to take that and substitute the 90 in for the area, and we're going to put in the base 2 is 12, and then the height that we're looking for, that height 2, is the DF that we're trying to find. So if you divide both sides by 12, then DF is going to equal 7.5 centimeters. Problem 3, we're finding the area of a triangle. It says a machinist is cutting out triangular metal braces to support the legs of a picnic table. Each triangular brace is 3 inches high and 2.2 inches wide. What's the area of each brace? So sketch this, the triangular brace, and the height here is 3 inches. And then the width is 2.2 inches. Okay, so we have 3 inches high, 2.2 inches wide. What's the area of the brace? Area of a triangle is half the base times the height, because it's half of a parallelogram. So it's half 2.2 times 3. If you want to plug that into your calculator, you can get 3.3, and it's inches squared.